guys still hear me? All right. Hey, everybody. Welcome back to the Howdy Partner episode. This episode, we have Confluent. But I think before we kind of get into it, I just want to say that Howdy Partner is a Twitch show where we discuss some latest trends in cloud technology and technologies in general. And we also invite our AWS partners, and today we're inviting Confluent to show their solutions and our platforms and the problems that it helps solve for developers, architects, directors, and everything in between. Now, without further ado, we're going to just introduce ourselves. My name is Eugene. I am a partner solutions architect here at AWS, and joining me is Eric. And Eric, I'll let you introduce yourself.
Hey everyone, this is Eric Vasquez. I'm a specialist hybrid edge SA here at AWS.
And joining us today are the wonderful folks at Confluent. Yeah, I'll let y'all introduce yourselves.
All right. Well, all right. Thank you. Thank you, Joseph. So most of you probably already know me. I'm just on the other side here, but Braeden, I am now a partner solutions engineer at Confluent. And I brought with me my new best friend, Joseph.
Hi, everyone. Joseph Relies, Cloud Partner Solutions Architect here at Confluent. And I kind of head up the partner relationship between the two companies. It's great to be with you today.
Cool. So again, I think today, well, what are we really going to be talking about? So I think, I guess before we dive into a little bit more into Confluent, I think a primer for the audience, we're going to be talking a lot about kind of IoT or Internet of Things and kind of edge technology. And I guess I'm going to talk a little bit about the IoT case, and then Eric, I'll probably pass it off to you to talk about some of the reasons why we should care more about edge technology. But specifically for IoT, there's a lot of things that's kind of happening in the world where we're really using Internet of Things. So if you have an Alexa at home, you have an Echo, you're driving a car that has software that downloads onto it, and all these type of things. These are all pretty big IoT use cases. So kind of just start off with just a couple of things. So for example, we have the industrial IoT use cases. And so a lot of manufacturing companies need IoT devices on their product line, or sorry, not product line, but in their kind of production line. So basically things that a typical industrial facility now has, I would say, thousands upon thousands of sensors generating data, which can be sent to a platform like AWS or Confluent to kind of see where potential bottlenecks, failures are during kind of the supply chain or the manufacturing process. So I think, that's going to be really important for a lot of companies to kind of remove waste and also, maybe leverage some predictive analytics that a lot, some platforms like AWS or Confluent has to kind of make actual insights on manufacturing equipment or anything along those lines. I think additionally, we also want to talk about the consumer IoT. So like I mentioned before, consumer is kind of where a lot of us are starting to use IoT devices. So home automation, voice enablement, like Alexa. And we also have home security. So, for the folks that have homes and they have security that monitors when you open doors, right? When windows are being opened, when windows are being broken, so on and so forth. Those are all kind of IoT, use cases now. And additionally, connected mobility use cases. So software-driven cars, where I think, if you have a Tesla or anything like that, a lot of these kind of, data and analyses go into the cloud now for, analytical use and things along those lines. But anyways, I think what I'm really trying to say here is the common theme is a lot of data is now being transmitted or transported to some type of platform for analytics and insights. And I guess with that, Eric, do you want to have anything to add about kind of some of the edge cases that you kind of see in the field?
Yeah. So when it comes to the edge in the field, we're usually seeing things regarding data residency requirements. Some of the workloads potentially can't go to the region, low latency requirements, and disconnected environments. So this could be maybe because it's a military operation or simply because, let me give you a use case here that I found pretty interesting. It was a golfing company. They own a few golfing spots, and their sensors are actually intaking data, but due to some security concerns, that environment needs to be disconnected at times. So this is a perfect example of maybe pitching in snow or a snow cone device in a disconnected environment using IoT green grass to control some of these sensors or control valves for irrigation purposes. So it's pretty random, but it just goes to show how powerful some of these devices are, and bringing IoT green grass to your on-prem environment.
So I think like let's bring in some of our guests here to kind of talk a little bit about their platform. We did talk a little bit about something like IoT Greengrass, about like the snow cone, like some parts of the snow family, and we'll dive a little bit into these services a little bit later. But we have guests here, and their platform is pretty awesome. So Braeden or Joseph, anything on your end that you guys want to share about the theme of kind of like IoT and just moving data into the cloud for insights?
Yeah, absolutely. Let me we'll tag team this one. So let's start with the actual data and the nature of it, right? So, and let's zoom out just a little bit, and we're talking about the fact that data is constantly moving, right? And we need it to be able to move or be able to keep up with that, because customers are expecting information all the time. They want us to be able to anticipate their needs. And so the reality is data is not static. And that's actually a whole premise of Confluence. And that data is always moving. So let me take a step back and ask Eric and Eugene, are you both familiar with Apache Kafka?
Yes, sir, we are.
Awesome. Perfect. Well, for those, sorry.
I'm not too familiar. So maybe you could briefly go over some of that for me.
Yeah, absolutely. And happy to. And for the viewers who aren't familiar as well. So Apache Kafka, and we're not going to be going super crazy, but at its core, Apache Kafka is a scalable and highly available event streaming platform, which you can kind of think of as your central nervous system of an enterprise, right? So Kafka makes it easy to get your data in and out of into an event stream platform, and then be able to do something with it and understand it, and then get it back into applications and systems that you need it to, right? So we're looking at real-time data, essentially, is what we're looking at. And again, the whole paradigm here is that data is in motion. We're working with event streams, streaming analytics, processing. And so with that, the thing that you need to know about Apache Kafka is that there are three things: brokers, consumers, and producers. Right now, if you really want to get into the nitty gritty, we do have some documentation that you can go into to understand Apache Kafka deeper. And I'll drop that link here in just a second in the chat. But we're going to focus on the core features of Kafka, again, as an event streaming platform, which is in order to let you and your organization work with that data in motion easily, Kafka provides you the capability to publish and subscribe to streams and events, to store your events durably and reliably, kind of like what you do with the database, and then finally to process and analyze those event streams, in real time, right? So a lot of times companies will start their data in motion journey, right? They realize, hey, we need to focus on moving data faster, and they do that by starting with publish and subscribe first, right? Pub sub, but then to think of Apache Kafka as just as that's pub sub messaging is kind of like thinking your iPhone is just a device to make or receive phone calls. Obviously, you can do so much more. Well, the same is with Apache Kafka, right? So with that, I want to invite Joseph to be able to chime in. Joseph, you want to jump in there? Let's introduce Confluent. Now that we've introduced Kafka and how it plays in the space of event streaming and data, let's introduce Confluent now.
Great. So thanks, Braeden. So Apache Kafka was originally designed by the founders of Confluent. So it was our three founders were all engineers at LinkedIn, and this was back in 2010. And they had problems that the web at the time and modern businesses didn't have, or they were starting to get, but they didn't have a solution for. So they needed something that worked kind of like a message queue, but had persistence, and it had to take advantage of the hardware that was available at the time. We're talking about like rack and stack servers. So the idea of Apache Kafka came up. Hey, let's persist the disk. Let's write to it sequentially, and let's make an immutable log. Well before people really got into the idea of blockchain. And then it eventually was part of the license through Apache, the Apache Foundation. And then Confluent started as a company just training people how to use Apache Kafka, right? How to install it, how to scale it, how to use it. And then through that exercise, the company realized that there were gaps in the product. It's one thing to be pub and sub, but it's another one to actually stream and stream process, right? Instead of, the classic model of Kafka was you'd have something like a Hadoop cluster against it, and it would be kind of the message plane and Hadoop would doing the processing. But why not? If you already have compute, why not do the processing there? So the Streams API became a thing, and we'll talk about that a bit later. And then, what if we want to connect to things that aren't Kafka? That's where the Connect API came from. And ultimately, we built something called Confluent Platform, which is where you can run our enterprise version of Apache Kafka with all these nice bells and whistles that make your operations lower and your development times faster anywhere you want. And that's an important part of our edge story, especially when you talk of Snow, Wavelength, Outposts, and local zones. And I'll get to that. We also have a fully managed product called Confluent Cloud. So that's in AWS in any region you want, and you don't worry about anything, right? You set it and forget it. You think of it in an AWS term, think of it as a fully abstracted service, not a containerized service, right? So we give you an endpoint, and you let us, the world's Kafka experts, manage it for you. So that is who Confluent is. So I'll bounce back to Braeden, and we can figure out what the next thing we want to tackle. Because Eric and Eugene, the way you guys kind of set us up for IoT got me really excited because I have a lot to say.
Yeah, absolutely. So with that, let's go ahead and kind of start nudging into. So what we have prepared for you all today is a couple of demos to be able to show you the power of data in motion in these various scenarios, right? So we mentioned and brought up the foundation of IoT, what it's like to be operating at the edge. We also have another demo that you'll be able to follow along with. Actually, both of them you can follow along with. We'll drop both GitHub repo links and the workshop links for you. Right now, if you want to be able to follow along, we're going to go ahead and drop in the chat confluent.cloud, and you'll be able to sign up there to be able to get a free account or get signed up without having to put in a credit card. We actually just dropped our paywall. That's probably one of the most exciting things that we've had in this first quarter of the year is that Confluent Cloud is now, you can sign up, you get a free $400 to use for the first, I believe, 60 days. And with that allows you to be able to build and experiment and try things out without having to worry about, oh, shoots, I forgot to turn something off or anything like that. And so with that, it is risk-free in that sense that you won't have to worry about that, putting in a credit card being charged without you forgetting about it. So with that, we're going to drop some links in there. Yeah, Eugene, yes, it is confluent.cloud. And let's see if we can find a specific site, Joseph. You could find that or share that with Eugene. But in the meantime, let's go ahead and I'll give you a brief overview of what we're going to hit. So like I said, we got the Edge demo, and then we also have a workshop that you'll be able to, again, walk through with us if you'd like to, or you could just watch as we demonstrate the power or the ecosystem of Confluent built on top of AWS. So with that, let me go ahead and, if it's okay with Eugene and Eric, hand it over to Joseph, and we'll go ahead and kick off that demo. Or Eugene, did you have one thing there?
Yeah. So I think before we kind of jump into this demo, we already kind of got a sneak peek and it looks super sick. So I think Joseph, you want to talk a little bit about some of the AWS services
Sure.
that you might be kind of leveraging, and then we can kind of explain that to the audience so that they have a good foundation. Just kind of seeing, why are we kind of using these services, why the demo will be using these services. Yeah,
absolutely. So what I like to do is I'm going to share just a couple. I know everyone doesn't love slides, right? But for illustrative purposes, I do have some that I would go through, and we'll start first the conversation with the AWS services, and we'll do that without slides. So one of the things that we have, it's really exciting, I'm going to talk about is a tool called Confluent for Kubernetes. So Confluent for Kubernetes is a tool that we built that gives you a Kube native experience for deploying Confluent Platform. So if you remember, that's our self-managed product that you can run anywhere. The nice thing about Kubernetes is it runs on Outposts, Wavelength Zone, and local zones. So, for anyone who's not run the edge services, there's a limited set. You don't get the full set of AWS services in region. So you got to utilize the best in breed that's there. In my opinion, one of the best services they brought to the edge was Kubernetes, just because of the inherent nature of being able to scale the underlying services and hardware independently of the actual application you're delivering. So, and Braeden can attest to this because he's done it many times himself. Once you have EKS spun up, which is the longest part of the process, but once it's up and running and you have kube control, you can deploy Confluent for Kubernetes within a minute. Like it takes about 3 minutes to start up, and you have a fully fledged distributed Confluent platform installed with all the bells and whistles. And that's one piece of the story. We actually use EKS on the background in the back to deliver Confluent Cloud. So we have a lot of confidence in both the tooling and the service itself. And we're just really big fans of Kubernetes. That's how we decoupled our compute from our storage. So setting that up. And the other one to call out is the Snow family. Now, the Snow family, we do have a blog post coming out this month highlighting how to use Confluent and Apache Kafka at the disconnected edge using Snow, and a really kind of beautiful cycle where, on a weekly basis, AWS is swapping out your snowball and you're getting that previous week's worth of data or whatever your requirement is. Someone once told me, and this applies to the edge because, I'm an operations guy, right? I don't know if you guys are former developers, but I don't like to run things, right? I've been on call. I was on call for 20 years of my career, right? And the worst thing you could do, the only thing that's worse than buying software or writing software that you can buy, is running a system that someone's willing to run for you, right? So when I think of, like an Outpost or local zones or Wavelength or Snow, it's really nice to know that Amazon and AWS is willing to deal with the interconnection, the maintaining of disks, the logistics that's all involved, right? So we also, because of our story with Everywhere, we tested Confluent running on Snow, and that also works as well. So you could do it through our Ansible scripts against EC2 running on Snow, or if you get Kubernetes running on Snow, which doesn't work out of box, but you can do it. You can deploy it that way as well. And so the point being is, if you want to leverage those edge services, you need a way to do it. Confluent for Kubernetes, and what we're going to talk about in the subsequent slides, are the technologies that Confluent brings to the table to make that easier, right? So you already have this well-established platform, Apache Kafka. You can talk to it with any of the clients. We have every single client. We have all these connectors, which we'll talk about in a moment. But you need to be able to deploy that everywhere. And then you also need to get the data from the edge back into the cloud. So how do you do that? Well, I'm going to tell you now. So let me share 1 second. I'll start here, because I like this slide makes me feel warm and fuzzy. So 1 second. Sharing a screen, and share a screen, and there we go. And you should be seeing a screen. All right, awesome. So the whole idea here, right, is that I'm going to be honest with you. Confluent's not going to start building data centers anytime soon. And we're not going to start deploying edge services, and we're just not going to do that. So what we do really well is we help people move data. So the idea is that, better together, we can create outcomes with each other, complementing each other, that we can't, provide you, the customer, otherwise. Our technologies layered on top of AWS storage and compute just go together really well. So moving on. We can create architectures like this. So I know when we talk in the edge story, this is kind of exciting. Being able to take our fully managed clusters in any AWS region you have, and they're all across the world, you can link them together directly. So you don't have to manage any of that. But if you do have the edge, you can leverage AWS's edge services to not have to worry, so you don't have to be on the hook for the storage in the middle of the night or the compute. And you can layer on our services to connect them all together. So you have all these different type of scenarios. And we're going to double click on edge aggregation in a bit. So this was Confluent for Kubernetes. I wanted to talk about this a little bit. It's something we're really proud of. It's something we shipped late last year. And it gives you this really declarative a way to manage your self-manage, right? So that's part of the story, right? You have this edge, but you want to be able to deploy it consistently. Having something that you could take the YAML for and check it into a repo and make part of your CI/CD process is kind of attractive, right? And that's exactly what Confluent for Kubernetes allows you to do. You basically, all of your cluster is managed through resource definitions. So if you want to scale out your cluster, instead of having 3 brokers, you would change the number to 6, and you'd kubectl apply, and it would grow. And there's nothing you have to worry about because our technology handles all the things that are happening under the covers. And then the ultimate kind of thing is it provides you with custom command line structures and commands. So for example, you could kubectl Kafka create a topic right through kube control, which for anyone who's ever managed Kubernetes or Kafka knows that those things usually don't work like that. So it's all the tooling that we realized, would help our customers being able to manage Confluent wherever they need it to be, right? Because you can't necessarily run everything in the cloud. We wish we could do that. Doesn't quite work that way in practice. So Confluent for Kubernetes, and this is just one more. This is what it looks like, right? You have, you can apply with kubectl control. The API, it's all YAML. It's very easy to see and make changes over time and look back at your code repository and see how your cluster has changed. Oh, look, we scaled it up, we scaled it down. Kind of a cool thing to do. So that's the part that makes the deployment easier, right? So now you have all the stuff everywhere. So you got Confluent Platform running on Edge, on Snow, in Wavelength Zone, in cloud, and across multiple regions. How do you tie that all together? Well, that's the other part of it, and that's our technology called cluster linking. So there are various Apache Kafka replication technologies. There's open source Maker 2. There's our own replicator. Those are built on the Connect framework, which we haven't talked about yet, but just keep that in the back of your mind. So it needs an extra piece for replication. And neither of those can natively match offsets. So we didn't talk about that. But in Kafka, when you write a message, an event to a topic, and that's how we divide our events into topics, you get an offset. So the first offset is 0. And then subsequently, as you go across, that keeps incrementing to the end of time. So when you replicate, if you start your replication after your topic begins with the other solutions, your offsets may not match. So your source offsets are different than your destination offsets, which for edge consolidation is not a big deal. But if you're doing something like disaster recover and failover, that could be a problem. So cluster linking is the latest and greatest technology. It's something we shipped last year as well. It's only available with Confluent Platform and Confluent Cloud, though you can cluster link an open source Apache Kafka cluster to Confluent Cloud with its. We're not going to go there. There is a story there for migration purposes, but it's the latest and greatest. It does not use the Connect framework, so it's all in broker, which is cool. So it's one less thing to worry about breaking, and it natively preserves your offsets. So it is a mirror very much in the truest sense. So the cool thing is you can have all your edge sites all over the place. And then you could say have an aggregation cluster in your favorite AWS region and have that thing scaled up to handle the aggregate data and then cluster link all of your edge sites to the aggregation cluster. Now you have all your data in one place. Pretty cool, right? So you got the tool to deploy the thing and then you got the tool to connect the things. Right? So you can see how we complement each other. So I just want to click on a couple other things. So when we show the demo, it makes sense, right? So we talked about this. This is clients. So every client you could possibly want, we have them out there. So it doesn't matter what you're developing, right? So you got this edge services, but you still have devices. They could be talking through MQTT. They could be talking through REST, but they could also be natively talking to Kafka through any of the clients you see here. We also have some really cool APIs. So I touched on this real quick. So this was developed after the whole pub sub idea of Kafka, right? Connect. We want to take things that aren't Kafka and we want to bring them into Kafka as events. We call those source connectors. But then there's also syncs. So we take Kafka events and we put them into other things. This is going to be really relevant for when Braeden does his demonstration of real-time decision making.
Sure.
But the thing is, this is a framework. It's open source, right? You got to still build your connectors. Now, the nice thing about Confluent is we've done that work for you. So it takes an average about 6 weeks up to 6 months to build a connector. And that's what takes the world's Kafka experts. So we have this really nice portfolio of connectors, source, and sync. So you can connect all your things together. So once again, taking the edge into the cloud, then taking all these different data sources and syncs and being able to get them to all integrate and work together at scale. And that's another piece I didn't talk about. Kafka works at scale. There are companies running Kafka at scale that are doing billions of transactions a minute, trillions of transactions a day. So whatever you can throw at it, it can appropriately scale. The other piece, and again, this is important because this is going to set up for Braeden later. is the streams. So this is where an API was added so you could do transformations of events. So imagine you have two input topics and you want to take those events and you want to combine them. That's a perfect use case. Or you want to filter, right? Maybe you got PII data, and before you sync it using Connect into a relational database that your data science team has access to, you're going to mask that data, and so it never leaves Kafka. That's another use case. Well, the problem with streams, it's not a problem, but you got to write it in a Java or Scala. And I am not smart enough to do that. So I cannot write streams. However, Confluent, and this is an example of a stream. So I'm getting ahead of myself. So this is what a stream looks like, right? But this is what KSQL looks like. So we built an abstraction layer on top of streams that allows you to do the same thing. So what you see here is a Kafka client executing a thing. This is what it would look like in Kafka code if you were a pure Java client. This is what a stream would look like. It's a reduction, but it's still, still Java. And then KSQL DB makes it simple as select, right? So I can write KSQL DB applications, but I can't write streams. I'm just not that good. If you want to play with this yourself, you can check out confluent.awsworkshop.io, which is the basis for the demo that Braeden will be running through today.
That's right.
And so we'll stop there. Those are kind of all the technologies that we bring to the table. And then back to Eugene's original point, which is where I kind of diverged, is all the edge services. We love EKS. We use it both on the edge and in region. We have tight coupling to private link. So our dedicated clusters in Confluent Cloud have private networking options through the means of VPC peering, private link, and transit gateway. And then finally, another one I want to call out, just two more I'll call out, is Redshift. Redshift was the first service that we built a fully managed connector for, and Lambda. So Lambda is special to my heart. It's one of my favorite AWS services. We have a connector to sync and evoke Lambdas, but Lambda also has a native integration for Kafka that can be utilized and leveraged and works with Confluent Cloud natively.
So just a quick question here. Do we have any plans of introducing Cloud WAN as a connector there? No, we added Transit Gateway, but selfless plug here.
We're open to any technology that our customers want to use. We haven't heard the ask for it yet. I could see that in the foreseeable future being an ask. But yeah, so this is a quick plug. So we signed an SCA with AWS. That's a partner thing, strategic collaborative agreement. And our engineering teams have been talking more than ever for the last 3-4 months. So I think there are some great things ahead in terms of, deeper integrations between the two services. So hopefully.
And I think we kind of went. Sorry, Eric, did you want to say something?
No, go ahead, please. No, go
ahead. So just wanted to kind of for the audience that's kind of viewing. So we're kind of throwing a lot of things at y'all. So MQTT, just a basic primer on it. It stands for message queue telemetry transport. It's just a lightweight, we were talking about earlier, lightweight pub sub network protocol. To kind of help transmit information between devices. So there's that. EKS is Amazon Elastic Kubernetes service, and basically it's so again Kubernetes going to, I don't want to go too much into the containers rabbit hole, but Kubernetes is just a container orchestration platform. You're gonna for the techies here, you're gonna hear that a lot. Actually, not even techies, for the biz dev folks, you're gonna hear that a lot. But basically it's, we were just talking something about managed services where we're kind of reducing the lift, the operational lift from a lot of folks, infrastructure operational aspect. And so EKS is one of our managed services that Confluent is happily, proud of to kind of work with. And additionally, I think one thing, Joseph, that you kind of touched on is that on-prem portion of it. And I think Joseph is gone because I just see a bunch of devices now. But I think going back into kind of the on-prem and just kind of where the current landscape, still a lot of companies are still on-prem, whether they just haven't wanted to migrate to the cloud, or typically if they just want to, keep some of their data and they just have more control over data, whatever that purpose is. There's a lot more kind of services that are coming out to ease that kind of transformation of migrating that data up into the cloud and so on and so forth. But just kind of want to make some points there. So audience folks, if you have any questions, please don't hesitate to kind of reach out and ask us. Because I think, I'm kind of just like saying this and we're preventing the demo from happening. The demo is going to, I think, be really, really cool. But yeah, I guess Eric or Braeden. Oh, sorry. Eric or Braeden. Any kind of follow up to what Joseph kind of touched over?
No, I'll save my stuff for later since I have my own demo. I'll leave it to Eric if he has any other questions.
No, I'm good. Also, definitely let's jump into the demo.
All right.
You can tell
let's
Eric's
go.
excited. You see that?
Nice.
Joseph switched to the devices, and did you see it? I saw that smile flash real fast.
All right. So before we get into that, yes, you don't see me. I'm still here. I'm just to the left of the camera. I'm going to share just one more. I just want to show a slide just to kind of set up what exactly you're seeing here and what we're going to be demonstrating. So if we can bring that slide up, Eugene, I'd appreciate it. Thank you, sir. So on the left side is what we're mocking up. Right. So the narrative here is around a factory use case. Actually, it's around agritech. So Braeden's going to talk us through all that. But this is where the demonstration started. So the idea is that you're connecting things in a factory, and you are natively producing. You can either natively produce or use something like MQTT. And Eugene, thank you so much for the explanation. To Confluent platform running in Wavelength Zone, which is exactly what we have set up today. I have Confluent platform running in the Washington Wavelength Zone. And I have a cluster link to a Confluent Cloud cluster running in the parent region, in this case, US East 1. And what we have here is we have over the 5G network, which is a really cool thing about Wavelength Zone. So the reason you want to use Wavelength is for two main reasons. One is you want low latency use cases, and also to reduce your security posture. So devices in Wavelength Zone can only communicate over the internet through things on Verizon's network. So that really shrinks your security posture by quite a bit. So what we have here is representing our factories. We have these IoT devices. We have a Raspberry Pi right here. It's connected to a MiFi. So that's how it's getting out to 5G. And we have a bunch of sensors that Braeden's going to walk through each of them. But what I'm going to do before I do that is just kind of to kind of fill this narrative out a bit. So the idea here is that these factory connected things would be sending telemetry into Confluent platform running here, and that you could then aggregate and do data reporting and things here. And you'll see SageMaker's called out, and I'll explain why. So we talked about streams. Now, streams actually allows you to run full-blown Java applications, and that includes machine learning models. So you could have a predictive failure model here. And then because of that low latency of Wavelength Zone, you could return things back to the factory and say, hey, shut this thing down. Something bad's about to happen. And you could do that right here. But you could take your aggregate data set and train it over time in your region. And then as your SageMaker model improves, you can then push that back out to the edge, right? So you get the best of both worlds. And then you get a scenario like this, right? Where you have many different sites connected, aggregating here. So instead of just one factory worth of data, you can have all your factories worth of data, building that model that is then going to save you money and time at the edge. So that's kind of the story we're set up. It's a slight pivot to agriculture. But what I'm going to do here is, oh, sorry about that. I still want to share. I just had to switch. Okay, cool. So let me share one more time. And then Braeden, you can walk us through the exactly how we want to contextualize this.
Yeah, absolutely. So with that, are you going to be sharing your screen?
Yeah, the screen. Yeah.
Okay.
That is not my screen, is it?
Oh, whoops.
That's okay. There you go.
That's your screen.
There we go. All right, perfect. So yeah, I'll contextualize this, give it a little bit of a backstory, if you will. So this is a demo that we built to be able to demonstrate the power of Confluent and Wavelength, AWS Wavelength Zones put together, combined. And we put it around the context of agrotech, right? Technology and agriculture. That's an industry, obviously, that sometimes technology is a little bit hard. They don't have an Ethernet port or an Ethernet cord running right behind their tractor when they're out there doing their things. And so with that, obviously, wireless is a very important technology that could very much benefit this industry. Now, we may be talking about agriculture today, but think for yourselves where you are in your own industry. this could apply to manufacturing, this could apply to oil rigs, and if there's a cell phone tower that could be near enough by, this also could apply for your use cases as well. So for the sake of just creating a story for this demo, we chose agritech. So with that, we do have a Raspberry Pi setup with various sensors. So you got temperature, you have humidity, you have soil moisture, air quality, motion sensor, and loudness. Now, it seems like a bunch of these just like random. We went to some Amazon.com store and we ordered a bunch of sensors, and I promise there's a story for each one of these sensors. And so we're just going to go down with each sensor and kind of talk about what's possible, right? And how 5G can affect these different scenarios that we've actually dove into a little bit. So with that, you're seeing the Grafana dashboard, which is live, by the way, and we'll get to how all of this data is flowing a little bit more, but you're seeing the data. And then on the Joseph Marai tile, you'll see the actual demo itself, the actual physical hardware that data is sending to that Grafana, right? So with that, let's jump right into that and talk about these sensors in this demo. So powered by AWS Wavelength Zone and Confluent, here we have, let's talk with, I'm looking at these. Let's just talk about the soil moisture first. Okay. So we're going to double click into that one if we can.
Yeah, no problem. One second.
Yeah.
There you go. Oh,
we'll just make it bigger so we can focus on that one. Right. So let's think of a farmer and all the different aspects that they usually have to deal with. And one of those is soil moisture, right? To be able to understand their field, understand, okay, well, how can I best take care of this field to get the best yield, to make sure that there's proper plant health, that it's getting enough, as it mentions or suggests, moisture, right? So obviously, water is a very important aspect, but at the same time, we don't want too much, right? So have you ever done the biology project where you've had to grow a seed and you have it in a little styrofoam cup? Typically, this is done in grade school.
I've killed a lot of those seeds, Braeden. I've killed a lot.
Yes, absolutely. What are you, Eric, Eugene? Have you ever done the plant the seed in the cup thing?
Yeah, it's a whole scientific experiment. You try to put the amount of water. You try you have different variables, right?
Yeah.
And see if the properties are correct. Yeah.
And there you go. Yeah, exactly. It sounds like.
Yeah, something to even add on to this is even if you're growing your own food at home, right?
Yes.
Hydroponically, you don't want to over irrigate your plants. You have to let them dry down first. And this is like a perfect use case here, just demonstrating the power and the tools that you have available. This is amazing.
Yeah,
let's show them the response time. Okay, so how we can simulate the change is I'm just gonna touch these together. So you see that? You see that spike right there?
Yeah, Joseph, maybe you can get it more centered in the camera. So if you're watching,
So you see it, right? And if I let go of it, it should go back to normal immediately. See that? How quickly that dropped down back to.
So the way that this works is that this soil moisture sensor has two prongs, and they're measuring the resistance between these two prongs. And so when there is more water present, there's more resistance, which indicates there's more moisture, right? And so that's how that's measuring it. So when Joseph is making that bridge or connection between those two prongs, it's simulating, hey, there's quite a bit of moisture. So we'll try once more. Joseph, are you able to touch those prongs? And you can see how quickly that shows up on this board. Boom, he touched it. And that was almost that was as real time as you feel you can get, and that's even considering.
Take a step back. The soil moisture is right here. So these are the actual events that are coming in real time. So when you see how that's 0, when I press it, that number should go up in a moment. See that number went up. The UI is not quite as fast as the actual data is moving. But this is what's happening. So we have the Confluent platform running Wavelength Zone. We're sending MQTT messages to it. It's being cluster linked to a fully managed Confluent Cloud cluster in US East 1 that you're seeing right here. And what we do is we do a little KSQL to turn our JSON into Avro. And then we have data integration here. So we have a connector that's syncing everything into Postgres. So it's running in RDS Aurora. And then we have Grafana using RDS Aurora as our data source. So even though we're going through all these hops, because wavelength is so low latency, because Kafka writes so quickly, because cluster linking is only off by like a millisecond, And because the networks are all so tightly together, I can be here in Philadelphia and I can press this and you can get almost real time. And think about like, it's even faster on my screen because we're sharing it, right? Think about all the latency we're adding just by the virtue of screen sharing, right? So yeah, if you needed to know if your soil moisture changed millisecond by millisecond, we can deliver it.
Absolutely.
So Eric, are you gonna buy it for your personal like farm, I guess, now? Because
Yeah. Like myself personally, I have to pay for dashboards, and you don't get real time metrics, right? This is maybe at best spaced out between 10 minutes. This is real time, allows you to make decisions or irrigation cycles, things like that, whatever it may be. So I'm sold on this. I want one at home as soon as possible.
And for people that are wondering about the latency, between writing the message and it delivering to Confluent Platform and Wavelength Zone, we're under 50 milliseconds.
Wow.
So it's like, to humans, 150 milliseconds is real time as far as they're concerned. So, Braeden, before you get into the other examples, I want to just call out the loudness. So we did this on very precariously live on reInvent stage. We did this demonstration. And the loudness was one of the easiest to demonstrate. So I'm just going to play some music, and we own the license to this, so don't worry about any copyright infringement. But you'll start to see the music will start to play out here, and it will kind of track. You can kind of hear it. The bass hits a little better, and then as soon as can you see it? It's kind of tracking, and then I'll stop it, and you'll see like it just drops. And it's all real time, right? So that's the one I love to show off just because it was kind of my baby. But then Braeden took it and made it even better.
Yeah, well, it's still very great. And you can still see it's picking up Joseph's voice. And I imagine you might have some speakers nearby too. Yeah, so it's picking all this up. But you can see it is picking all that up, and it's real fast there. So with that, there you go. There's the loudness sensor, right? We did demonstrate that at reInvent. But hey, there's also a use case there when it comes to agrotech, right? So, pests are a very well-known thing when it comes to farming, right? So, I mean, you don't really necessarily want certain things eating your crops that, could cause disease. Could obviously have effect on your yield. And so, maybe having a loudness sensor out in the field, or multiple actually, could help you identify, hey, you know what? At any given point in time, this area right here is a little bit louder. Perhaps you can identify the frequency, right? So, locusts and bees have a certain frequency that they hum at. And if you have these sensors out there, you'll be able to identify, hey, there's a whole set of locusts coming out there. I forgot the plural word. It's not a herd or a flock.
I think it's
loci. But what would you say? Loci. Like it's a herd of loci? You know what I mean? Or it's a flock?
It's a murder of locusts. No, that's
a swarm.
A swarm. There you go. Thank you.
Obvious is always the most difficult to find.
I know, right? So with that, you could listen for a swarm of locusts just using that sensor and measuring that frequency, right? So that's another use case there. And the other ones, there's quite a few other ones. I think temperature and humidity are quite obvious. It's very important.
Which one is that? Which one's temperature?
So that one is the square box looking one. It's mesh. One? Yes. And you can actually
the blow on this. Is that what?
Yeah. If you go kind of like do like a breath test on it, where you go like that.
Oh, wait, hold on. Give me 1 second. Let me put it back on the stream.
Okay,
there you go. Yeah. So you actually see the humidity and the temperature spike thanks to Joseph's wonderful minty fresh breath. Yes. So obviously you're not going to see that kind of dynamicness, or maybe you might in real life or in nature, but hey, it's important to know. And this is also important to measure at even a more more specific plot of land, because you think about it, when I get my weather, I'm in Dallas, obviously I don't know what it is right now, 72 degrees. It's not 72 degrees everywhere in Dallas, right? It's going to be probably 74 degrees, a little bit more north. There's going to be a little bit more humidity down south, right? And so that kind of broadness is not as useful. Well, having these kinds of sensors will be able to help you measure down to the specific plot of land, right? So that you could be really precise. And this is actually something very big for those who aren't into precision agriculture, precision tech for agriculture is something very interesting, because it definitely helps out, again, with the fact of yield, of overall plant and land health. And yeah, so with that, that's another example of the power of 5G, AWS Wavelength, and Confluent, getting that data to farmers faster so they don't have to go out and collect that data. So back before this kind of wireless technology, and maybe even sometimes today, for those who don't have access to that, have to have a robot go out there and have all these sensors and measure all of these different metrics. And it'd be nice because you get this kind of data, but the way you would get it into the cloud to be analyzed, as the farmer has to go out, drive out to that robot, pull out the hard drive, put a new one in, and bring that hard drive home to upload it to the cloud. Imagine doing that for X amount of robots. You have 50 for 50 different parcels of land. You're going to have to go out there and drive around and collect all of those hard drives. And then think about how many times you have to upload that data. And imagine now with 5G, with this AWS wavelength and the ability to be able to get it to the farmer instantly, right? They don't have to wake up 3 hours earlier because they have to go drive around collecting data from robots. The data now comes to them, right? And then another question is, not only does it come to them, right, with Confluence, and we'll talk to this a little bit more, and Joseph kind of touched on this, we can now transform that data, right? Not only can we just get it to the farmer, we upload it to them to the cloud. Now we can start doing analysis on it by transforming it, tweaking it, discovering and exploring this data so that we can better understand the fields in the way that we've never been able to before. Right.
Yeah, perfect example of that is the temperature and humidity sensor. You'll notice that was the same sensor, but we're getting disparate. Right. So what we did using K-SQL-DB is we took the single stream, we split it into two, and then we inserted it into different tables, and that's how we were able to do that. So it's a very novel and small and minimal example, but it's a good one. I'm laughing about the fact that when I was blowing on the temperature and humidity, that the air quality got worse. So I don't know what that really says about me, but like I'll prove it to you. I don't know why I did it, but it's not even the same sensor. I swear the quality went worse. But anyway,
that's funny.
Yeah, like maybe something else that I'm just thinking out loud here in terms of use case. Even firefighters, right? When they're rushing into a building, CO2, oxygen levels, things like that. You can actually just track this on a dashboard if you're maybe running the operation from the outside, making sure that the folks trying to save people are safe themselves.
Right.
Yeah.
At least minimum
action the fact that the CO2 is spiking, right? Like there's so many different ways of looking at it. And I'm sure there's people in the audience that they're thinking about that agriculture example and going, well, I know wavelength zone is only in 17 North American cities and another, handful of cities worldwide. What's that going to do for me in the middle of, Idaho? Well, good news. AWS offers private MEC, which they will deploy an outpost. And again, this isn't your mom and pop farm. This is a big, massive, commercial farm that would deploy an outpost somewhere in some central area. And then if North America, Verizon would come along and wire their entire campus, their entire farm, mega farm for 5G connectivity. And then that poor farmer would no longer need to get the hard drives from the robots.
Right. Absolutely.
So I just want to quickly, I'm going to bring this back to focus on. So I think just quickly going over what wavelength is, what wavelength zones are, what what carrier gateways are. So wavelength is just basically, as you've already kind of seen being demonstrated, it's just an AWS service that basically enables developers to kind of build applications to deliver super low latencies with mobile devices or even sensors, right? And basically the what we're kind of really piggybacking with is kind of the 5G networks that are available. And so in this case, in the US, predominantly is going to be, for example, Verizon. And in South Korea, there's SK, and there's a couple other carriers that we have on wavelength. And so I think what a wavelength zone is, as kind of described earlier in one of Joseph's slides, is that it's just basically a zone in where it's a zone where the carrier location like exists, right? So in the case that Joseph was kind of saying, like, in Washington, right, in Seattle, you're going to be able to deploy like a wavelength zone there. However, like if you're in the middle of Idaho, you can like you're gonna have to probably like like pivot to something else, like using Outpost. So just kind of want to like have like a little primer about kind of wavelength, just so that everyone's kind of on board. And last but not least, carrier gateway. That's just kind of like if you're familiar with like with AWS, with things like internet gateway and stuff like that, it just basically allows inbound like traffic from carrier networks. And again, in the specific wavelength zone, and it allows outbound traffic to the carrier network or the internet. And I think with that, I kind of want to actually bring it over to Eric, to talk a little bit more about Outposts, and then we can go right back into some more demos.
Sure.
Okay. So with Outposts, it's one of the few services that's actual physical infrastructure. It's a 42U rack, industry standard, comes ready to be rolled into position at either a co-location facility or in your on-prem data center. So you have the same AWS experience, the same VPC constructs. You have all that AWS workflow on-prem for you to either experiment with in a dev and test environment or a production workload. So it could be agriculture. It could be because of some type of compliance standard or data residency requirement that you have, or maybe it's your initial onboarding step into the cloud. But I know Joseph mentioned this earlier. A lot of people like EKS and just Kubernetes in general. So that's something that's supported on Outpost. We have many other services. And if the service isn't available there, you could just talk to me or any other AWS SA, and we could work with your team to hopefully get those releases for you as quickly as possible. But Eugene, if you need me to go more in detail, just let me know.
No, yeah, like I just kind of want to like have like a primer for the audience members, right? I think like this is super cool for some of like the tech folks that are on here, and I know like from like the comments themselves, it sounds like everyone's pretty amazed by the demo already. But just want to have like a primer so that everyone can kind of like understand what like we're talking about when we're kind of saying like, hey, you're out in the middle of Idaho, all right, let's just rack something up with like Outposts and stuff like that. So no, yeah. So Joseph, I'm gonna throw it back to you and see what else you got in store for us.
Great. So Braeden, we got one more sensor. Let me switch over to my IoT cam. Let's call it that. And you could set that one up. Which one is the air quality? Oh, you're muted, Braeden.
Sorry. Yeah, sorry about that. So there's a cylindrical canister looking one at the
Is
tip.
that this one?
Yes, that is the air quality one. So this is
Is that the motion sensor?
That's the motion sensor one, yes. So there's a different one that's
This one. I got it.
Yeah.
Just by process of elimination.
Yes. Yeah, that's it. Right there. So this one is the air quality sensor. Now this will measure different dangerous gases, carbon monoxide, CO2, formaldehyde, all sorts of.
That doesn't look good.
No, it doesn't. So luckily, I believe this is more, I'm sure that shows us breathing on it or something like that. But whoa, there you go. Right there. So what we've done is we've simulated by using hand sanitizer pollution. So in the case of agritech or agriculture, pollution obviously will have an effect on the yield of the crops. And so, this will be able to provide farmers with data so that, hey, if you ever want to go to legislate or help, get legislation passed to be able to make sure that your crops are healthy for, be able to work with other companies to help make sure that they're in line with, making sure that the environment's doing all right, then this is a key data point that they'd be able to have is, hey, here we can see the actual effects of how it affects my fields or the crops there. So another aspect here is that there could be some degree of remediation. Maybe they can cover the plants. They can create some pollution resistant variants of that crop, right? So they have options, but they won't be able to know what to do until they actually have this data. And again, if you think about it, it's not enough to have that general or broad data for, hey, in Dallas, Texas, there's an index of 2. I don't know. I'm not a pollution kind of person. I
If
don't
you
know how
have
we
an
measure
index of
pollution.
2, you better
Yeah.
not be living in that area.
Yeah.
Is that good? Is that bad?
Yeah, who knows? But in any case, you can now deploy these sensors at very specific locations and get precise data for that specific location so that you can make a decision and not just make a broad sweeping one for your overall land or farm. Right.
Yeah.
So
Braeden, something you touched on in Confluent Cloud, we have this thing called infinite storage. So you can make a topic grow as long as AWS doesn't run out of disks. Your topic can grow infinitely, and you can retain forever. So if you have this type of information, you can look at your trends not over days or weeks or months, but over the entire history of the implementation of this solution. So it is something that's pretty cool.
Yes, absolutely.
Yeah, I was just about to ask you roughly the same question. Historical data for me to pull metrics to see how maybe crops are performing or whether or not I had a dip that could potentially lead to a reduction in production or things like that. But that's good to know.
Yes.
Very good to know.
There you go. And then this was just measuring the sensor. And you can kind of pair this with the loudness sensor. Hey, is there a pest nearby that I could play on a speaker to make the pest run away and stop eating my plants, right? So here's another example. But, the whole idea, and I'm glad you brought that up, Joseph and Eric, is Apache Kafka is all about getting data or streaming data, moving it fast and getting it somewhere. Confluent extends that and is able to transform it. And then with AWS, leveraging AWS for, hey, we're going to use 5G or the wavelength zone. And then we're also going to leverage the scalability and high availability of AWS. You can see how Apache Kafka, AWS Confluent, there's a best of all worlds there, right? To be able to make this solution that now makes the lives of farmers or anyone, perhaps you could apply this to an oil rig or, somewhere super far remote. And now they can have this kind of data come to them. Again, they don't have to go out to pick up the data manually. It just comes to them. They can transform it. They can understand it. They can do whatever. They can send it downstream to other applications now. Stuff that wasn't available before is now available. We have rescued that data from the edge, and now we can now use that.
Right.
So that's
data.
Yes. Yeah. There you go. So that's that's demo. Hey, yeah, Eugene, Eric, are there any follow-up questions for this?
Yeah, so I think I like that. Well, I can't really speak for Eric now, but I haven't really gotten too much involved with the industrial kind of verticals over at AWS. But it just seems like I guess if you can kind of speak more to it, a Confluence next series of customers going to be farmers. I mean, we're talking a lot about farming. We're talking about humidity. We're talking about soil quality. We're talking about air quality. So I just I feel like a low hanging fruit question type to ask.
So yeah, no, this is an interesting pivot. So it's data, right? It's data. It's a novel set of data, but it's a growing data source, right? Like the numbers I saw was something like IoT devices will generate 65 zettabytes of data per year in the year 2025, some ridiculous, unfathomable amount of data that you can't even imagine. But where we're strong already, and I think, yes, I think there are use cases that AWS services now unlocks the power of using data in motion at the edge, and we can start talking about these things. But where we're really strong is in financial services already, because banks, when you're talking about events, banks are very much into immutable logs and things happening in order, right? Because you don't want to withdraw $30 before you deposit $30. Otherwise, you've stolen money from someone. And if you deposit it before the money actually comes through, you've just generated money from nothing. So financial services got on board with Apache Kafka very early. We're very strong in digital native. So any popular ride-sharing app or anytime you've ordered food through an app, is a very high 9 out of 10 chance that your order went through Apache Kafka. Because again, that's an event, right? I want food, and now my food's ready. That's an event that I want to order it, and that generates something that happened for the restaurant. The restaurant then cooks it, acknowledges it's done, which triggers the driver. The driver, these are all events, and they all have to happen in ordering. But anywhere, honestly, any data that you need to move, whether it's legacy attached to old sources through Connect, or newfangled technology like this with robots doing MQTT, and anywhere in between, Apache Kafka and Confluent can help you.
Cool. Awesome. So I think right now is a good, I think, like time to, well, let me first, are we done with kind of looking at the Grafana dashboard? Awesome.
Yeah,
Yes.
I'm gonna stop sharing.
Cool. And so, yeah, so I think like what we've kind of really touched upon today is, again, like the theme is moving data right into the cloud and what we can kind of do with it. But something that, that was just demonstrated earlier, like, just right now is pretty much the different type of data sources that's available now. And I guess, more and more things like I feel like industries that we don't really like consider to be like quote unquote cloud native or like high tech are all kind of going to veer towards it because it's going to make life simpler. You're not going to have farmhands or like really bad sensor giving you outdated information for you to check on like a set of crops or whatever, right? Instead you're going to have it like live in real time. And I guess like using Confluent and like AWS Wavelength, you're going to get it into pretty much 50 milliseconds, so it's going to be literally in real time.
Great call.
Awesome. So yeah, so I think Braeden, is there just check in, do we have another demo for us to kind of take a look at as well?
Yes, we do. So if you're ready to pivot to such, we have the Confluent AWS workshop and I'll go ahead and share that in this chat real quick. And here we go. So there it is right there. This is a workshop that is another example where we highlight the best of both worlds of, we got Apache Kafka, we got Confluent and AWS, and we're seeing what it looks like for that to have to build a solution that plays on the best of each of these technologies, right? So with that, let me go ahead and, are you prepared? I got my screen ready if you're prepared for
Bam.
this. Perfect. So what we're going to go and do is we're going to log into Confluent Cloud. And let me go ahead and share
actually,
this.
sorry, Braeden,
Yes.
before you go into Confluent Cloud, I have to do a shameless plug.
Yes.
Because you're on a certain like that workshop is hosted on like a certain domain.
Yes.
So if you are a partner of AWS and you're checking this stuff out, here is the main domain link where you can look at all the other different types of partner workshops that we've created. Not to take anything away from Confluent right now,
Sure,
but
absolutely.
it's a shameless plug. This is something that I've worked on a lot, and this is something that again, if you're a partner, what you're seeing Braeden and Joseph kind of demonstrating today is something that you yourself can kind of like use, but that's going to be the final shameless plug. And I think before we kind of move on into like this next section, I just kind of want to quickly recap everything that we've kind of gone over. So again, in the beginning, we kind of talked about like what the theme of today's like episode is going to be, which is going to be IoT, right? And we talked about some of the use cases there. We talked about the industrial use cases. We talked about commercial use cases. We talked about connected mobility use cases, right? And we talked about how certain things, certain Amazon services with our partner solutions such as Confluent is enabling very different segments of the industries to kind of move their data into the cloud. And so we talked a little bit about like kind of EKS, which is just again a container orchestration platform or service. We talked about Wavelength, what can that do, and to kind of make sure that your latency is ultra low, so that we can have a cool demo like which is Joseph showed us, where everything is almost in real time. Well, pretty much in real time, at least in the human perception. We talked a little bit about Outposts, right? Kind of like just services at the edge where you could have either disconnected disconnected like edge services. We talked a little bit about the Snow family, how you can kind of store data. So I don't think we talked too much about Snow, like the Snow cone, but Snow cone is basically an actual, I don't want to say briefcase because it's not as big as a briefcase, but like, Eric, do you have one to show us that's by you right now?
I have one downstairs. If you want to give me like a minute, just
so
to quickly...
yeah. So you run down right now, and I'm gonna just kind of keep talking, recapping. So Snowco is just like an actual hardware, right? Where there are some AWS services that you can run, but basically when you're in remote areas, right, that you want to get data that way, you're gonna be able to with some of these snow cones. And I think overall, what we really discussed today, and with the demo that we've had, is pretty much kind of showing you like, using Confluent data in motion, you're going to be getting something, you're going to be getting like, all these different types of data, novel data sources. We always think, as I think developers, we always think about like, application logs. We always think about, CloudTrail logs from an AWS perspective and the CPU utilization, right? And that stuff is great. And that's still a really big part of like modern day technology. But I think, again, what Joseph and Braeden really showed us is that like there's a different type of like data source that's coming in that is spreading, I think, a huge portion of like the rest of the industry that may not have kind of tapped into the potential cloud. And so, yeah, Eric, if you want to kind of show like a snow cone, it's
Not
not,
sure if
yeah,
everyone can see it,
it's not
but
even a briefcase.
yeah,
Here,
this
hold on, let
is
me.
a snow cone device, pretty small, ruggedized. You could run EC2 from here. You could run a lot of services from the snow cone itself. So not the most powerful tool. We have Snowball devices also that come in a bigger form factor, but extremely useful for many of these use cases that we're talking about today.
So do you have just like a size comparison that you want to show? I don't know if you have like a banana next to you. I don't know that I know
A
that's like a
banana.
typical.
Wow. How is that the first thing you thought
I
of?
would say just
That
look
is
at
a standard unit
my
of
size
measurement. It's
comparison
banana.
right here.
Is that a lunchbox?
It's a snow cone.
No, to the right or on your left hand, I guess. Is that a lunchbox?
Yeah, what are you comparing it to?
It's kind of like a little small booklet.
Okay.
Okay.
So
yeah,
to
like
give
so
you a
basically.
size comparison there, it's extremely small.
Huh.
So yeah, like I guess like that's just to say that like the snow cone is something that you can literally put in your backpack and then you can go hike to a very far away place that does not have a wavelength zone
Yeah.
or
I'm not
anything
gonna
like
lie, I
that.
want one of those. I didn't realize how small that is.
Yeah, we'll get you
Yeah.
one, Braeden.
Yeah. They look pretty rugged
Uh,
too. I mean, not that I plan on surfing on it or anything, but like, it looks drop proof to some degree, shock proof.
It is.
I think
It's ruggerized, so it could survive a fall up to a certain level when it comes to blast radius and things like that.
Cool. Well, there you go. Well, thank you for sharing and showing.
No worries.
cool. Yeah, no. So yeah, let's Braeden, sorry, yeah, to throw it back to you. Let's talk
No,
a
no
little bit more
worries.
about this workshop.
Yeah, so here we have a workshop that demonstrates using Confluent Cloud on AWS. Now remember, Confluent is an extension, or we extend Apache Kafka, right? So Apache Kafka has scores, they had to be event streaming platform. Well, Confluent's built a whole ecosystem around it. We have connectors, we have KSQL DB for stream processing, right? And then we actually just host the clusters and manage them for you. So really all you're doing is pointing, clicking, making sure that this application or database over here is made aware of by Confluent cluster, and then Confluent can ingest that and transform. And so we're going to do all of these different things through this workshop, and you're going to be able to see the different features of that ecosystem and why Confluent makes it so much easier for you to be able to use Apache Kafka or get your data in motion without having to worry about all that undifferentiated lifting of, hey, I need to get Zookeeper up, or I need to be able to make sure I have enough disk to make sure that my topic has enough space to write into, right? So things like that we'll be able to demonstrate. So with that, again, we dropped it here in the chats. We'll do it. Let's see if it's like, we'll do it one more time just so you have it more recently. And again, if you want to follow along, you are invited to be able to do so. So let's go ahead and drop this Confluent Cloud as well. Try, and you'll be able to sign up for a free trial, and then we'll be going to be able to. Let's try this one right here. This will be easier for everyone. Here you can sign up for Confluent Cloud account. Again, it's free. There's no paywall. We dropped that earlier this year. You don't have to have a credit card. You'll get a free $400 to be able to use if you want to be able to use that with to do so right now to follow along. Right. So with that, I'll leave those there. In the meantime, we're going to walk through this. I will say I've gone through one of these steps already to make sure that you didn't have to sit for about 40 minutes for a CloudFormation spin up. But here's what we're going for. All right, so there's going to be a graph here. So this demo is going to demonstrate the power of data in motion in financial services, specifically when it comes to credit applications and it's simulating people applying for different types of credit, mortgage, personal, car, all those types of things. And what we have here is simulating the dynamic data that's coming in, say from Bob, and they want to apply for X amount for $100, and it's just going to be for a car loan, right? And then we got the more static data that doesn't really is not new, right? So we know Bob's address because he has an account with the bank, and we know that we know his phone number already. So that stuff isn't going to be so dynamic. But now what's going to be interesting is we're going to be able to ingest both the dynamic and the static data and be able to combine that together, be able to process it in a way that makes sense and make a decision actually on whether we'll reject or approve the application. And we'll be able to sync that into Redshift using one of our connectors. In fact, we're going to be using multiple connectors here, two of which we'll be able to deploy. One here for the MySQL, another one here for the Redshift. And then from Redshift, we're going to be able to visualize that using Amazon QuickSight, which is the dashboard solution, which we'll show a little bit later. So this is the end goal of what we're going to be building today. All right. Now, if there are any questions regarding the components or this architecture, please do drop them in the chat. You know, Joseph, Eric, and Eugene are all monitoring and very eager to be able to help answer those questions for you. So with that, we're just going to go ahead and get started. All right, so I'll go ahead and share what the prerequisites are. It is important you have an active AWS account. That is where you're going to be spinning up some of these resources. And then that you have an active Confluent Cloud account. And again, we dropped that link in the chat for you to be able to sign up for a free account. No credit cards, no worries about having to get charged by accidents because you forgot to turn something off. Right. Now with that, it'll walk you through signing up. We are on AWS Marketplace, so if that makes it easy for you as well, you can set it up that way. But we'll go ahead and set it up. We'll start here, right, with creating a Confluent Cloud cluster. And I'm going to go ahead and do that. Now, I already have one already set up and associated with our demo today, but I'll go ahead and do this live, this specific portion live, because I want you all to be able to understand the difference between spinning up a cluster in Confluent Cloud and spinning up an Apache Kafka cluster live. In fact, let me defer to Joseph, because you know what? Joseph has actually done this, in a previous role. He's actually had to manage, on-prem, if I understand correctly, Joseph, on-prem Apache Kafka servers. Is that right?
Yes, both
yes.
On-prem, like back in the day when I had to worry about spinning up zookeepers and brokers, and I had to think about running out of disks or my SAN running out of space or no longer being under warranty from EMC. And then also in EC2, where I had to worry about are my partitions too hot, that I pick the right instance size, that I pick the right disk types, all those things.
Yeah.
So, yes. Yes. Running things when someone else will run them for you is a good thing.
There you go. Perfect. Thank you so much. That actually hit it all. I was going to say, can you dive into the mindset of somebody who has to manage these kinds of things? You kind of hit it. You kind of all noticed all those different aspects. Do I have to worry about storage? You have to worry about whether some partitions are being written to more often than others, right? Yeah. So there's an imbalance, all of those different types of things. And then in terms of setup, Joseph, what is it like to just start from scratch and set up a new cluster? What does that look like? For just
so when we did it back on prem, back in Urban Outfitters days, we were using still pretty predominant configuration as code tool called Puppet. So we're using Puppet to do the orchestration and the install. But the thing is, it's you got to time it just right, because you got to have your zookeepers come up first, then you got to have your brokers. It was hundreds of man hours to get the Puppet manifest and all of that working right, and all the Ruby scripting we did to make it work. And even then, it was prone to failure. When we got to when I did it at the startup and I did it on EC2, it was a little easier at that point. I was using Salt Stack. And the configuration was easier because I didn't have to worry about the hardware anymore. I didn't have to think about all do we have to add another blade server? I didn't have to think about those pieces. But it was still complicated, right? I mean, you still had Salt Stack, and once it was in production and it was lit up, there was still something else to think about. And it's not, that's just the running the Kafka piece, right? There's hundreds of things that are producing, and there's hundreds of things that are consuming, and you got to worry about those too. So not having to worry about one of those pieces is a nice thing.
Absolutely. So with that, I'm going to show with you now what it's like to be able to spin up a Kafka cluster, giving that background that Joseph shared. Now that we have Confluent Cloud. Now here's our page here. You can select different types. We're going to go with the basic for now because we're not going to be doing anything crazy. But please do explore. We have standard cluster, which is for production ready, and then we have dedicated for those higher traffic use cases with private networking requirements as well, right? So we're going to go ahead and begin this. Now we are going to be in US East 1, and we're just going to go ahead and click continue. And we're just going to say new cluster for now. We're not going to use this one specifically, but I just want to be able to share with you what it's like. And you can configure some of these other things, configuration costs, and all those other things. But there it is, right there. And your cluster is ready to go. You can go ahead and create a topic.
I could not spin up a Kafka cluster of my own that fast. I guarantee.
That's right. Yes.
Can't do it.
And we're just going to do test because that's always a fun name.
It won't spin up on Docker that quickly. Locally.
Yeah. There you go. Yeah. So there it is. You are literally instant Kafka, right? Or Apache Kafka cluster right there. And you can already create a topic, and you can even produce a topic or a message to this topic. Let's go ahead and produce to it. And there it is. There you go. And I'm waiting for it. I think I have to put the offsets. There you go. So with that, I might have stopped it early, actually. I might have stopped it before it actually got to send. But we'll be able to send data right now. We'll see that soon. The main thing here, I just wanted to show you is how fast you can get that cluster up, okay? So now that we've seen that, here's the actual cluster that we'll be using for the rest of this demo. Again, we had to do a little bit of prep so you didn't have to be sitting around waiting for a cloud formation to be going, right? So we're now going to be, I already created the cluster API keys, but this is going to be keys that you're going to be using to be able to interact with your cluster. Think of them as access keys, the equivalent AWS access keys. All right. And then this is the schema registry. This is where we're going to be able to get our Bootstrap servers. There's a little bit more, but we're not going to go into that necessarily for the time being. But schema registry is there typically to be able to help make sure that for data validation, right? So you want to make sure that you're not just getting random inputs and that's going downstream, breaking your applications, throwing error logs all over the place. You can stop that all the way up front and say, you know what, this isn't right. Let's stop this right now and even prevent you from going the rest of the way from here. And then, so that's what schema registry is usually used for. We'll get to that point a little bit later down into the demo. All right. Now you'll notice a lot of this is quite a bit of setup, but once all that setups, all it takes is a few clicks and you'll be able to see this data flowing through. Next step here is we're going to create the KSQL DB application. Now, remember, KSQL DB is the stream processing abstraction layer above Kafka streams or K streams, right? So, before K streams, you had to write a custom Java application to be able to transform that data in real time in Kafka, right? Now, over time, they added some framework called the Kafka streams, and using that framework, they cut that code down by a little bit, but you still were limited to having to use Java and Scala, I believe. And then from that point on, Confluent built on top of that, and we've abstracted even further more. And now you have a SQL-like syntax to be able to do that stream processing. So now you don't have to know Java, right? Which I'm sure many do, but a lot of us more younger guys, I think it's a little bit more rare for us to know Java. I think Python and JavaScript are basically the main things. TypeScript, any other languages, Eric and Eugene, that you've been seeing pop up that are more popular these days?
Go.
I think you're making me feel really old. I know.
I'm sorry. I didn't mean to do that. I didn't mean. I apologize.
No
yeah, but Go, like Python, all that. Yeah.
Yeah. So with that, this obviously will make it a lot more accessible for those kinds of developers. So with that, we're going to go ahead and create that KSQL DB cluster. All right. We're going to click through this, and we're just going to call this Howdy partner KSQL DB. And this is the app. Again, this is going to be the application upon which we're going to create that stream processing, and that's going to start provisioning there. So while that is doing that, we've already launched that stack, and we can go ahead and make sure that we're in North Virginia, we're in the cloud formation, and then there it is, the Confluent workshop. All right. So with that, next step is we're going to go ahead and create that topic. And so I'm not going to keep flipping back and forth. I'm afraid I'm going to give people some whiplash here. So what I'm going to go ahead and do is I'm going to move this workshop over here to my other screen. And you're just going to watch me work as if this was a normal demo, right? So with that, we're going to go ahead and create the topic. And we're going to name this credit applications. And this is, if you remember that architecture diagram, where those applications are going to land coming from that Lambda function. That Lambda function from earlier, again, is creating those mock applications saying, hey, this is Tony. He's applying for X amount, and it's for a house, or it's for a car. It's for a refrigerator, right? And so this is going to be the topic where that data is going to land, right? Now, next piece, we're going to go ahead and double check. Yep, KSQLDB is still spinning up. And so we're going to go ahead and take a look at creating the connectors. All right, so let me go ahead and share the diagram once more so that we can kind of get a visual of where we're at. So all of this is set. Yes.
I had one question about like kind of connectors. I guess like, I mean, probably can't tell specifically, but like how do you determine like which connectors to kind of like create to kind of get some data sources? Obviously we see like like Snowflake, we see like Lambda, but I guess like, you know, just wanted to ask, how do you guys like come up with like which connectors to build for which data source?
Yeah, so, you know, very much like AWS, sometimes it's going to be driven by what the customers want, a little bit of reading between the lines and understanding what the customers will want, but they don't realize they want. And so, you know, Joseph's been around a little bit longer. So he's actually been here for what, a year and a half, right, Joseph? And how
almost two.
And how many connectors has Confluent built?
Oh, God. When I got here 2 years ago, we said 100 plus connectors. Now we're at, we lowball it, but it's really 150 plus.
Yeah.
So 50 over 2 years. Now, the thing is, we went from 10 to 100 in a year when we made a big push. So to answer your question, Eugene, it was kind of like, let's figure out what the most popular data sources and sinks are, right? Mm-hmm. The relational databases, HDFS, all the message queues. And now it's more like ISV services and cloud native services are the ones that have been developed later on. And to Braden's point, we have field feedback of very similar to what AWS does with PFRs, and we track what customers are asking for. And if the customers are a lot of customers are asking for something, we will build it for them. Or our partners build connectors as well. So for a good example, like Snowflake built the connector for Confluent, but we then go and then validate them.
Yep. There you go. Thank you.
Cool. Yeah. Thank you.
All right. So with that, we are now at this piece right here. So we've spun up the application. We have all this other infrastructure up. We have the cluster up. We have the topic ready to receive data. We're going to go ahead and create this pipeline right here. Now, again, these connectors, you know, we take it for granted that, hey, we're just going to spin a connector. Before connectors existed, you had to do this yourself. You know, whether it be just straight up Java using the Connect API or framework there. Which, you know, does make it simple, but it's still something you still have to develop and support your own. Whereas with Confluent, we provide you that pre-built connector and supports. If anything goes down, you're not the one who has to pick up the phone at 2 a.m., right? So, hey, I need help with this connector. There's something wrong. You get to sleep some more. So with that, we're going to go ahead and spin up this source connector right here, and then later down the road, we'll spin up the Redshift one. So with that, we know that it's a MySQL database, so we're going to go ahead and look at the MySQL source. It might be obvious, but we'll go ahead and the sources are going to be getting data out of the database here, and then the sinks are going to be putting data into it. And so we're going to be using the source one here since we have an existing one. And I'm just going to go ahead and start filling out some of these configurations. Let's see here, legacy MySQL source. In the meantime, do you have any other questions about connectors or the setup so far from either of you two? Let me see.
No, I mean, it seems really straightforward. It seems really easy.
Okay.
Like really simple to set up. So yeah, no questions here.
Perfect.
+1 on that, and I don't think there's any questions on the chat right now. So
okay, perfect.
Cool.
So with that, I'm just populating all these different things, and I actually don't mind sharing some of these this walkthrough, because I do feel I 100% would prefer to be copying and pasting some values into some form rather than building this out on my own. And so with that, let's see, grab the admin password.
Yeah, and in the advent of Apache Coffee, if you wanted to do something like this, before the Connect framework, what you would do is you would build a producer application. So you build something in Java that could log into the database or whatever, and then would do a persistent select statement or something along those lines. The way we do it now is we look at redo logs for change data capture. But you could just time bound a query, and every time a new result came back from that database, you would then produce natively to Kafka. So eliminating that and building a scalable framework in Connect, because Connect it's scalable. If your database, if one task is not enough to pull the data at the rate in which you're writing to it, you can add a second task, a third task, and horizontally scale it out, and then it will split up the select or well, I guess you can't do that with change data capture, but with certain connectors, you can scale that up to get more throughput. And then it's highly available.
There you go. Yeah, thank you, Joseph. So with that, you all saw, it took a little bit, but I copied a little all that information in there. And something I'll highlight here is that this is where it's going to be outputting. So when we're going to be receiving it from the MySQL database, and we're going to be using the tables here. We're going to be taking out credit payment history and credit utilization. These are going to be the relevant tables that now, something that as we're deploying this, we may be using this for our demos as purpose, but think about this in a migration sense, right? Instead of you having to plan this huge, lift and shift to be able to get a database into Confluent, into AWS, into RDS, you can simply use Apache Kafka or Confluent to use this connector to get that data asynchronously and super quick and in real time into that database without having to worry about any performance issues on your database, as well as the fact that you don't have to worry about cutting over and worrying about losing any data, right? So you have this, it's going to bring over all the existing data and because it's a CDC or change capture or change data, or what is it? Change data capture connector, you're going to be able to get that new data too. So as soon as you're up to date and you're ready to switch over, it's as easy as pointing that endpoint to your RDS to which you've sunk into using Confluent and the connectors, and you can go and decommission that legacy database on-prem. So with that, we're just waiting for that connector to spin up now.
Yeah, while we're waiting on that, why don't I give you guys some background about how we built this demo. So this was originally built out for one of the top 3 credit score providers, right? So anyone's ever had to deal with their FICO score knows about these credit providers. So the narrative was around how we are approved or rejected for credit. And it comes from kind of a real world example where you have your two values, right? One is how utilized you are. And that means how much credit have you been issued versus how much you're using, right? So if I have if my only thing I have is a $10,000 limit credit card and I'm using $1,000 of it, I would be 10% utilized, right? Simple math. That's one factor. And you want to be less than 30% utilized. If you're over 30%, that's one reason they would reject you. Another reason is how often you're paying your payments on time. So it looks like it didn't like the secret there, Braeden.
Yeah, it did. No, I'll update that. Thank you.
Yeah, that's an easy copy paste there. So the other part is how often you make your payments on time. So they look over 3 years for all your major payments like mortgages, car payments, things like that. And you want to be over 90% paid on time. So if you're over 90% paid on time and you're under 30% utilized, your FICO score factors in, but those are like major decision points. And we added that into the demonstration. So the idea is that your utilization and your payment history are sitting in a MySQL database. And that's your data at rest. And it's not changing very often. But then people are constantly applying for new credit applications because they want a car or they want a credit card, whatever it is. And that's the data in motion. and you want to marry that together. You want to take that not changing often data and the new data and then make a decision on it, so that instead of waiting a week or 2 days to figure out, did I get rejected or was my application accepted, you instead get it in real time. And once we get over this hump with the connector, we'll do the KSQL DB and we'll show you some magic.
Yeah, absolutely. It's just not like I apologize, everyone. I guess I'm not as great at copy and paste as I thought. Give me one quick second here as I.
Yeah, worst case, you'll have to delete and recreate the connector. Again, this is a little hurdle in terms of just copying and pasting keys. But this is like one of those things. Once you set up, you don't really do this again. You know what I mean? So this isn't something you're playing around with too often. There you go.
We'll just generate that one.
Yeah, it'll just populate it for you.
Yeah.
And for any hackers out there, we're going to delete those, so don't worry about copying it.
I know, yeah, it's already.
Like somebody's like, "Oh man, I just screen captured that."
Yeah.
so we'll delete the heck out of that.
So yeah, we might have to, just because it might, but that's fine. We do have a working environment here pretty soon, so what we can do is just restart that process there. So. You know what we're going to go ahead and do is we're going to try and figure. Oh, I guess we do need the data before we can.
Yeah, you can't get around that connector. You might just want to delete it and recreate it.
Yeah, we'll do that one more time, and if not, we'll switch over to the new what's it called, the new one, or the created.
Yeah, we have a back. We anticipate these things.
Yes,
right? We're professionals here, so
yes.
We have another fully baked cake that we can pull out of the oven and show you.
All right, so with that, we're going to do this one more time. And I'm gonna be really quick about this the copy paste here.
And you could pull the new API key right from the thing you downloaded.
Yes.
Because otherwise you'll hit the limit. It's right there. It was in your download.
It was. I actually deleted that one just now.
Oh, you did? Okay.
Yeah.
Well, right, okay.
Real
cool.
time.
Nice.
There you go.
Nice.
All right, and hit this one. So as we're watching this one, all we're really doing is we're configuring to make sure that this connector knows exactly where to point and look for the database. And so, we're going everywhere from port to the actual database itself within the, database name. So this one's going to be Confluent demo, and we're going to, we want it to be secure. So we're going to use SSL. We're going to prefer that. All right. And then here are the table names, right, that we're going to be pulling from this MySQL database. Oops, it's not what I wanted.
Right, so that first table is going to have the 36 months of credit payment history for our sample 100 users, and then utilization is going to have that information about how much debt to how much credit they're utilizing.
There you go. And I believe the last piece here is we want it in JSON, and we want one task. Now, real quick, as I spin this up, Joseph, could you explain what tasks are in the context of connectors?
Yeah, we were touched on that a little bit. So this is how you horizontally scale your connectors, is the number of tasks that are
that's right. Yep, sorry.
Yeah, no. So we start with one. So that means one process is going to spin up and is going to read that database, and it's going to write into Kafka. If two, it would be split amongst two, and so forth, so on and so forth.
There you go. With that, let's see. We're going to wait for that. KSQLDB is here.
That's good to go.
Yeah, it's good to go. And you know what? What we can do is we can start walking through these KSQL queries. So
yeah, you could do the first. You could do the stream, the credit application stream, and maybe show them the Lambda while we're waiting for the other piece.
Yeah, let's go ahead and take a look at the Lambda piece. Where's the Lambda? Oh, here it is.
Yeah, so we have a Lambda that fires up, and that's the one that's going to be producing the credit applications for us.
Yes, absolutely. So I actually need to pull up a terminal real quick and grab that, because this is what we're going to be using to kick off that Lambda function.
You got to pull out your curl commands.
Yes, that's right.
Great.
Goodness, I'm trying to. Here it is. All right, we're going to clear this one out. And here's what we're going to do is we're going to, and I'm going to have to reconfigure my screen here.
And just as a quick intro for the folks joining us now, we're currently working on the secondary demo. Braeden and Joseph from Confluent are showing us the art of the possible here today. We first started off with Snow, some of the edge services at AWS using wavelength and 5G. And now we're going to do a credit report demo. Should be pretty interesting.
Yes. All right. So I had to. I didn't want to share the key. I know that's you're thinking of, I just wanted to hide that for at least that portion. So now
All
what we're going to
good.
do is we're going to get that URL. You want to see any other funky things coming through that API gateway.
That's right. That's good.
All right. So then here's this URL. Put that in there. Do that real quick, and then we're going to go ahead and curl it. And so this is going to kick off that process. Now it's going to time out. There wasn't a return or anything like a 200 or anything like that, but we know that it's going to kick off, and we can check that. And let's go ahead and check on our connector. Look at that, it's running.
Oh, look what timing! So let's check.
Yeah.
Yeah, let's check the credit apps topic first. But that's awesome timing.
So here's the credit application. Let's see here. There it is. It's already popping in. So you can see it as it's being created. These are the customer ID. Who's a customer 85? Well, we'll figure that out when we make a join later down the road with that static database material that we brought in.
You may have noticed when Braeden went to the topics, there are two other topics that are new as well, and those are our tables.
Yep, that's it.
MySQL.
So you can actually see here. This is it's producing to it. We can actually see it. It might have been done by this point, but we can go ahead and go to offset 0.
And Braeden, sorry to interrupt. Can you maybe zoom in just a little bit on the screen?
Let me go ahead and do that. How's that looking for you all?
I think that's much better. Yeah.
Yeah, and if you could full screen, if that's possible. There you go.
There you go. Okay, perfect. So it's going to look a little big on my side, but that's fine. So with that, we got the credit utilization. We got the so here we got all the database tables that we need from here. We also have the credit applications coming in currently. So what comes next is the actual KSQL DB. And so with that, we're going to go look at the KSQL DB queries that are provided for us. Now, remember, this is going to be real-time stream processing using SQL syntax. And so what we're going to do is we're going to, and let me, do you all see that okay? Does this also need to be zoomed in?
Yeah, I think
good. Yeah.
Good? Okay.
Yeah.
So with this, what we're doing is we're creating the data in a form that could be used by KSQL DB. So we're creating a stream, right? And so that's going to represent the actual events in order, kind of like a log, whereas a table is more is more of like what you would think of as a table. It just maintains a state of the states, right? And so we know instead of having to synthesize all the data, crunch through it, and aggregate it, and understand where we are in terms of the state, we have both forms. So you can use both, right? And so
do you mind if I explain it the way someone explained it to me? It was very helpful.
Yeah, absolutely.
So with streams, you have these two concepts. You have streams and you have tables, as Braeden mentioned. So think of a stream as a chess match. Okay, so think of a chess match, right? And we want to do that. So a stream would be all the moves starting from the beginning of the match up until the current state of the table. Okay, so I move my pawn up, somebody moved their rook, et cetera, et cetera, et cetera. The stream would be all of those different moves. The table would be the current state of the match, right? We don't care about all the events. We just want a snapshot of what it looks like today. And those have different reasons, right? Streams, you may want to watch the series of events to look for anomalies. Tables, you may just want a point in time look of what do things look like at this moment when I'm asking for it. Yes. And that's how streams and tables differ.
Thank you. Thank you very much, Joseph. I do remember that. And it's funny because I love playing chess. I just can't believe I totally forgot about that example there. But yes, that is exactly right. So with that, we are creating the data in a form that we can be able to manipulate it. And so you can see here, we're creating the streams, we're creating the tables based off the topics that we have. So you can see here, and we won't go through every single one of them, but we're using the Kafka topic here, the MySQL credit payment history, MySQL credit utilization stream. And so what we're going to do is we're going to copy and paste all of those, and we're going to go ahead and enter it into the KSQL DB. We're going to run that query. We're going to come down here for a successful result. All right, and there you go. It'll take a little bit to load. There you go. So we could read through all these, but I think it'd be easier just to show you. There it is. There's our streams. now that we have those in place, you can see we've already started some degree of transformation, right? We had to rekey the credit utilization, and I believe these are all in JSON still. At some point, we're going to make those into Avro, right? And there's the tables that we have, right? So now we have our foundation, we have the data, and ready to be able to be further transformed. Now, what we're going to go ahead and do is we're going to create two streams, one for approved applications and one for rejected applications. And what that's going to look at is going to look at those various factors that Joseph was talking about, all the way from who is this customer, what is their background, what is the credit amounts they're looking for today, and then their history. Have they paid on time historically? What percentage of debt do they have in relation to their income? All those different things. So it looks like for now we're looking at where paid on time is greater than 90%, and that might be for simplicity's sake, that might be the only factor that's being taken into account. And then if it's less than 90%,
it's the more than 90% and less than 30% utilized, which is the less than at the end. And
there it is. It gets cut off at the bottom there. I see it. Yes.
And then the other one is the opposite. If you're less than 90% or equal to or over 30% utilized, it's a reject.
Perfect. Wonderful. Yes. Thank you. I didn't see that line go past there. So with that, let me go ahead and paste that in. And what this is doing is it's joining. It's making all those different joins between the tables, those streams, and creating an enriched stream that can allow us to be able to get a full picture of who these customers are and what their history is at the same time. So with that, I have that data you can see here, but the way I like to see it done is just I go here. What it does is it creates a topic in which we're dumping these different approved applications and rejected applications. So at any point in time, we're here pretty soon, we're going to be able to see these messages flow through, and it may take a little bit and there it is. Now, we're not going to be able to read it because we missed it, but we actually changed it to Avro.
If you want, query it through KSQLDB and you'll still be able to see it.
Yes, exactly. We can't query that through KSQLDB and see that. So let's go ahead and take a quick look. Streams, and let's just go ahead and look at the approved applications. And look at that. So we can just go ahead and click query, and that's nice and easy.
We always show approved because life has enough rejection.
There you go. So look at that. Someone just got approved for a $50,000 mortgage. Wow, what a cheap mortgage. Who wants that? I do. All right. So
you can see in those numbers,
50 grand mortgage,
that the approvals match what we're looking for, right? So this individual was percent paid on time was 91%, and their utilization was only 2%, which is really, really low.
Yes. So with that, we now have data that's been processed. We've applied logic to it, and we have decisions. So the next step is let's go ahead and get this down into downstream so that our applications, our underwriters, or whoever needs this information can now use it, right? So the next step in this process, and let's take a look at this diagram once more, is going to be syncing from Confluent Cloud into Amazon Redshift, right? It's using that connector, very similar to the MySQL one we use, but this one's going to be a sync instead, right? So with that, we're going to go through this process one more time. We're going to go ahead and click into data integrations. We're going to look up Redshift. Add connector. And we're going to look up Redshift. Now, again, we have over 150 plus. For those who do want to be able to see all that offering, Joseph or Eugene, are you going to be able to drop that link to the connectors?
Yeah,
browse through them all. Yeah.
So, we have Confluent.io/hub. So for anyone out there that's familiar with Docker, it's kind of similar to the idea of Docker Hub. You can go there. You can search for your heart's content. Right now, the results are 214. So there's some redundancy there. So that's why we say 150 plus. But you can find whatever you want there. And we even have tooling that allows you to automatically pull down connectors through Confluent for Kubernetes or through our UIs. So just like you would Docker, right? You would just like import. You would give it basically the namespace and the link, almost like GitHub, and you pull that right down. You get your latest and greatest connectors.
There you go. And I don't know if you noticed, Joseph, but did you notice this new interface for creating a
It's
Redshift?
much nicer. You have some leading spaces on the Redshift domain that are going to burn you.
Yep. Thank you. Yep.
That's all right. It is finicky, like any type of input schema or validation. Yeah, they did. They actually. It's more of a flow
Yes.
for the audience and for Eugene and Eric. It used to be kind of all one page. Now it's kind of step through and much more simple. Actually,
Yes.
it's a good one.
There we go. So we're going to go ahead and create those. I believe I captured everything to make sure. Oh, I need to set the database time zone. Oh. I captured all of those different ones. And this one should be a lot simpler. I do like this flow more. Task. And with that, let's go ahead and give it this awesome name that we have, Redshift Connector. I believe that is everything. So let's give that a try. So again, we're creating the sync connector. And once that's complete or finished, all of the data that's in the two, and I apologize, I didn't share with you which topics we were looking at. Let's see if we can look at those settings real quick. You can. So we are looking both at, and I pulled the wrong ones. It's a good thing I caught that. So we're actually looking at the rejected applications and the approved applications. So let's go ahead and see if we can catch up.
So I think like while we're waiting for that run, I guess like, one question I had is like, this is very much, I feel like in like what you're like the actual workshop that you're doing right now, the scenario you're going through right now is something that banks actually like use. And so I guess like my question here would be like, what would be like, if for example, if there are developers on the stream right now or that are watching it after that are kind of like interested in like diving a little bit deeper into like kind of the financial services like use cases, like where would they kind of find that?
Got you. We have an amazing website called developer.confluent.io, which is really going to dive deep into building data in motion applications, right? And then whether you want to use a data source, that you already have, it's just a matter of finding the right connector and adding it to one of the recipes that you'll find there. And if you want to use a downstream service, chances are we already have a connector for it that'll make that happen for you. So developer.confluent.io, great question, Eugene, is a really fantastic resource.
There we go. Thank you, Eugene. So with this,
Yep.
We're actually going to go ahead and set up QuickSight so that as soon as it's ready to, sync everything, we'll be able to use it. So we're going to go ahead and get this run ahead so that's all we have to do is wait for it. So we're going to get rid of this analysis. We're going to create a new one. We're actually going to add a new data set. And you can see from a previous demo that we've done that. We're going to go create a new one. And we're going to use Redshift. So we're doing the auto discover. Here's our cluster that we have. We're going to name this approved applications.
And so QuickSight, sorry. And so sorry for everyone else. QuickSight is just basically one of your like services that does like dashboards. And so basically you give it like a set of data and then you can create a whole bunch of colorful dashboards with it. Sorry, go ahead, Braeden.
No, that's it. Thank you for that introduction. Have you used QuickSight for any recent projects or anything like that?
Yep.
Yeah. What did you use it for? If you're able to share or high level.
Yeah, just kind of like looking at Salesforce stuff for different purposes and showing. Yep. I think that's the only thing I can say.
Yeah, that's fair.
And maybe Joseph or Braeden, there's a question in the chat from Six Partitions. It's regarding the cost of the connectors and whether or not they're similarly based to what we're showing.
That's actually a great question. Six Partitions. That is a very apt name for a Kafka conversation. That's actually how you scale topics, as you partition them and you spread them across brokers. But yes, so our fully managed connectors are all priced at the number of tasks and how many and the hours that they run. So there are some premium connectors like Oracle CDC that I think run a little bit more expensive, but that's like the outlier. 95% of them are going to run at the same cost. And you can absolutely start experimenting with that free 400 hours in credits that we give you and the no paywall. And even if you don't have a MySQL database to source from, we do have data gen source connectors. So they will generate data for you. And then you can start experimenting with stream processing and then, spin up something like RDS Aurora in AWS, and then you have something to sync to. So you have a really nice opportunity to experiment and play around with the technology.
All right. So I know that we're getting pretty close to the end. So let's take a look at a different environment where I did get this just in case, where we did get it working, right? So we got this Redshift connector. It is running. So what we can go ahead and do is we're going to go take a look at, and I have to pull up a different region. So the one we were working live is in US East 1, just so that we don't run into any issues for this one. We're going to go ahead and take a look at US East 2. And we're looking at quick sites where we have been able to, in this region, already populate that data. Again, it's already been transformed. It's been brought in. It's been joined, processed. Now we just need to look at the actual data itself. So with that, you can see this is sourcing that data from Redshift, and we can take a look at let's go ahead and look at a pie chart. And we're going to look at the amount versus the credit type. And so we can see based on what we're working with, and actually, sorry, let's take a look at, maybe I switched that in amounts. Yes. So you can see a majority of what we're working with or people that are applying, or actually a majority of are applying for personal loans in terms of amounts, right? If we did an account of how many people were doing it, then we'd be able to see that. But in terms of amounts, we're just seeing a lot more money being asked for in terms or in the context of personal loans, while mortgage and credit cards are more or less similar, right? So, to wrap things up here, again, this is what we've been able to do, right? So we've taken dynamic data, joined it with more static data by bringing it into Confluent using those connectors that are pre-built for you, and using KSQLDB to process that data in real time. You didn't have to batch it. You didn't have to wait 5 minutes before it was, landed into Redshift. It was being done in real time as it was read, as it was being written to Confluent Cloud, and then put into Redshift for you. Again, using a connector that was pre-built and provided. And then you can visualize that using Amazon QuickSight. So with that, that is the conclusion of both of our demos, the power of AWS and Confluent and Apache Kafka on AWS. So do we have any questions from the chat or from Eugene or Eric?
I don't think there's any questions in the chat right now, but I think what I wanted to ask is are there what ways can the audience members get involved with if they want to learn more about Confluent, if there's any upcoming events,
Yes.
and things like that.
Yeah, I'll list out a few. Joseph, catch me if I miss any. So we have this site here that's events at .confluent.io. This is going to be the go-to place if you ever want to figure out if there's something near you. I know that we have something called Data in Motion Tours, where we're able to go and talk about Confluent or Apache Kafka in general to all of you. So I know that there's one coming to Dallas in May, so you'll have to check that out. We also have AWS summits in which we'll be present at those. There's the one in San Francisco that's coming up in a couple of weeks. Joseph and myself will be at. We'll also be at the AWS summit in New York, Ontario. What are the other ones, Joseph? I might miss one.
We're doing most of them. We have Berlin, we have Toronto, we have Sao Paulo, we have Madrid, we have Milan, we have Atlanta, New York City, San Francisco. So as Braeden mentioned, we're doing most of the global summit. So if you're at a global summit, look for Confluent. You'll find us there most likely. We have a Data in Motion tour. We have Kafka Summit. We will have a not yet named, but to be announced very soon summit that is not Kafka Summit. So there's going to be a ton of opportunities to work with Data in Motion Live wherever you are in your region.
There you go.
Brandon, I think to kind of showcase all that, what we can do is, Brandon, so since we still kind of have your screen on there, you mind? Yeah.
What would you like pulled up?
I think if we go to events.confluent.io.
Yes. Confluent.
I do have something cool to share before we close out.
Yes. So here's my screen here. real quick.
So let's go back to that. And so I think like this kind of just captures at a high level what folks were kind of talking about. So like the Chicago, New York, Atlanta, the Data in Motion tour.
Yeah, and
I'm
I'm
fun.
signed in, so
Yes,
I might,
click on all events. I think
Yeah.
it's like it's waiting for
Oh,
you
there
to
we
go to
go.
event type. Yeah, try that.
yeah, so yeah, because I'm signed in, so you might see things. There we go.
There
So
you
you got Data in Motion tour. There's New York. You also got some online stuff that's if you wanted to, you could do it in what's it called over on the web. So you got plenty of things. Here's the Kafka Summit in London, where we'll also have some place or stuff. We got Data in Motion tour in DC. So here's an example, and then Joseph, what was it that you were wanting to share?
Oh, so if you just if you show them
Okay.
screen, this is the loudness sensor for the entirety of the event. that we did
Look at
today.
that.
So this is what our conversation and all of our audio looks like through the course of the stream. So I just thought it was fun. The thing's been
I'd
running the
imagine-
whole time listening to me. What's that?
I'd imagine that's how my noisy neighbor's house would probably be.
It's just a solid block.
when the shoe hits the wall, right? So,
You know what you should do is you should have a sensor and then just give them, just be like, hey, here's an iPad. And when it ever gets to like this decibel level, like, I'm going to call the cops. I'm going to call the cops.
The iPad turns red.
Well, I think Braeden, Joseph, thank you so much for coming on the show today. It was very lovely to have you and talk with you about kind of like, some of the things that are really kind of changing multiple industries with different data sources, with the ease of use of I think some of the connectors that you've shown us today of transporting data, and basically pretty much really only having to, and let me just kind of correct me if I'm wrong, but it sounds like from the data sources and syncs and everything like that we were moving the data from and to. It sounds like all you really have to do is really focus on some of like the SQL commands to kind of get what you want, because you're kind of getting data in pretty seamlessly and easily. So
yes,
Exactly right.
absolutely.
well, anyways, I think thank you everyone for joining today's stream. I believe what we'll kind of leave off with, and Braeden, correct me if I'm wrong, but I also want to just kind of do a shout out. Like Braeden was actually one of the founders of this these type of like this show. And Braeden, as you know, we're gonna give you 3 different phrases to choose from: happy trails, giddy up, and y'all come back now.
Yeah.
So I'm gonna let you choose, and we're gonna end the show with that.
We'll do happy trails.
All right.
All right.
So
we'll just do it on a count of 3.
Yeah. Ready?
Ready.
1, 2, 3.
3.
Happy
Happy
trails.
Trails.
All right, y'all. So join us. I believe we have something next Tuesday, or sorry, not next Tuesday, next Wednesday at 2 p.m. Pacific for our next show. So take a look out for that. And yeah, at the thanks again for everyone for joining, and we hope to see you next time. Peace out, everybody.
Thanks for having us.